Hello everybody, this is the second set of notes on Lewis dot structures. I want to make this as quick as possible, so here we go. Please know, once again, that Lewis dot structures only matter for metalloids, other nonmetals, and halogens. Even though noble gases are nonmetals, we don't care. They already have a full energy level in their outer ring, so we don't care about them because they're already happy. We only care about metalloids, other metals, and halogens. And then know that hydrogen has one valence electron. We skip 2, we skip the transition metals, and then this group has 3, this group has 4, 5, 6, and 7. First thing I want to do for you is to show you the answers to last night's homework, or the homework you should have done today in class. There's 22 problems on here. There's no way you got through all of them. Now, I am fully aware this may not be the easiest thing to see. My document camera is nice, but it may not show fine detail. So I'm going to show you these answers as best as I can, but when I get home this evening, I will post a better scanned copy of this key so you can see all of the answers. Number 1, 2, 3, 4, 5, 6, 7, 8, 9, O2, oxygen, that has a double bond in it. Instead of holding hands once, it holds hands twice. That has a charge on it, so you add or subtract. In that case, since it has a negative charge, you add another electron. This has a positive charge, so you subtract an electron. Those are 10 and 11. Number 12 also has a charge. 13. 14 is nitrogen. It has a triple bond. 15. 16. 17 has 2 double bonds. 18, 19, 20 has a double bond. 21 has a triple bond. And 22 has a double and a single bond. So there are all the answers. I'll get a better version of this posted so you can see it better, and then we will do more of these problems tomorrow in class. Now what I would like to do is point out that on the homework for tonight / tomorrow, I would like to show you, this is the second worksheet, but if you look at the back of this worksheet, there are some little notes on how to draw Lewis dot structures. You can read through all of these, and that's what we've been doing. We've been adding up the valence electrons. We have been filling all the octets. We've been doing all of these things. But what I quickly want to show everybody is that there are 3 exceptions to the octet rule. There are 3 times when we will not have 8. Obviously, we know that the octet rule means 8. There we go. We know the octet rule means 8. Well, there are 3 times when things won't have 8. We already know 1. Hydrogen only needs 2. It's going to start with 1 because it's in the first column, but it does not need 8. It only needs 2. The next thing says groups 2A and 3A. Those used to be this group and this group. Well, we no longer call them groups 2A and 3A. We call them groups 2 and 13. What it says here is those two groups, those two columns, 2 and 13, do not need and should not have octets. Well, let's simplify this even more. We don't even care about group 2 because they're all metals. And we don't care about group 13 because most of them are metals. The only thing we care about is that one right there. So let's reword this. I'm just going to cross that out, and we're going to make this rule so much easier. And that rule now is boron only needs 6. If you have boron in your Lewis dot structure, it only needs 6 valence electrons. The last one we'll keep as written, but we're going to try to make it a little bit simpler as well. What this says is central atoms in the third row of the periodic table and below may get 10 or 12 valence electrons. Let's put that into English that's a little bit easier to understand. What this is saying is, once again, we only care about the metalloids, these others, hydrogen included, and the halogens. We don't care about these. So what this is saying is that if we have any of these elements, if we have any of these which are in the third row or below, if we have any of those elements and they are the center atom of a molecule, then it is okay for them to have 10 or 12 electrons. Let me show you this as an example by showing you the first problem on the homework tonight. If we do this like we did every single problem on the first worksheet, phosphorus has, if we find it on the periodic table, it has 5. Fluorine has 7, but we have 5 of them. If we add that up, this picture is going to have 40 dots in it. If we put phosphorus and we put 5 dots around it, what we end up doing is putting a fluorine on every one of them. Fluorine gets 5 or 7 electrons, but since we have 5 of them, we have to put all those on. What then happens is this has 40 total dots. Count them. You will see 40 total dots. You will see 8 around each fluorine. But if you look around phosphorus and count those, it has 10. That sounds like a problem, but if you go back to the periodic table and find phosphorus, it is in the third row and below, but it's in the third row, it's in the middle of a molecule, it's okay if it has 10. So continue to try to do these. We will do Lewis dot structures all day tomorrow in class, and I will see you tomorrow.